Thank you so much, and thank you for your patience. And yes, sorry that I'm not allowed to travel at the moment, but here we are. So my name is Margaret Samuels. As uh, I was just introduced, I work at NASA Goddard Space Flight Center, and I'll talk to you about a few different spaceflight mission applications that we've gotten to apply here with 3D printed electronics. So just our group here, the overall goals include having the capability for that customization that additive manufacturing, of course, is known for sometimes very unique needs of our spaceflight missions, but also to minimize cost and schedule. And we really approach this with two overall prongs or ways of approach. Our first and foremost core is always research, and that, is defined for us in terms of having a very specific application that we need to try to develop the technology for. But secondly, we've started breaking into some rapid prototyping, and that's really useful for some of our big, high-profile, low-risk missions that need boards and parts tested early on. And this enables early testing without long lead times, and getting those design flaws worked out earlier in the process means a lot less cost overall to the projects. So this was our first thing that we got to actually fly. We printed a basic housekeeping circuit on the inside of a sounding rocket door. And looking at right here is where our door went on the Subtech 9 mission in April 2023. Oh, that's right. I have to go next. So this is just a little close-up showing that we had milled pockets with some parts dropped in and filled in with polymer, including an accelerometer. And we did have printed temperature and humidity sensors. And our middle circuit printed directly on the door worked for the entire 12-minute flight. And we got it back. And so we actually got some data. So that was super exciting for us. I'm kind of going to jump around a little bit. So our next flight opportunity, we got to print an antenna for a balloon test flight project last summer. And just for those of you that don't know, if you haven't heard of the Balloon Program Office, the Scientific Balloon Program, definitely go check it out. It's a website that's really well laid out with pictures and graphics. It's a great one to get your kids interested in science. But they do a lot of really exciting science on very small budgets on these scientific balloons. They do 10 to 15 launches per year all over the world, some here in the US, some from Sweden, some from Antarctica. So definitely check it out. But here's the mid-latitude antenna. It sits on the gondola, as it's called, the payload for the balloon missions. And that's the antenna we were kind of trying to emulate and perhaps replace. So before we get too into it, I always like to point out the timeline we had for this project because it definitely directed a lot of the choices. Our funding got turned on May 15th of 2024 for a flight happening in August of 2024. So 3 months to flight, 2 months to ground testing that we really wanted to be able to make. Since we weren't going to get to transceive during flight, it was even more exciting to have ground testing, more important. So this is supposed to go automatically, and it's not. So the, sorry about that. The antenna is being printed here on the right with the Bot Factory SV2. And this was a magneto-electric dipole design printed on radix, which was provided by Rogers Square. It's a tunable dielectric that is also printed, I believe, using SLA, SLS printers. And we were not going to get to transceive during flight because we were too late to the RF safety plan, but we did want to get to that ground to satellite testing before flight. And also, we purposely did not cover it in anything, a radome or anything like that, so that we could understand how the ink held up to the atmospheric conditions of the balloon. It's not going. There we go. So here you can see our very sophisticated satellite ground testing setup. And we got to compare it to the heritage antenna that's usually used for these balloon flights. It's a basic bifilar helix antenna that is hand wrapped around a fiberglass rod.